Yeah, see, this is where it gets weird. For me, it's one of those weird things about why this is offset like this, and there's some kind of glue on, some paperwork, photon, and 2 pi or 4 pi that works out for the physical geometry or the axiom proof that says, well, that worked. As long as you describe it like this, and the periods and the mods and the stubatoa, it'll get there. It's actually not a bad way to get it, but it's a weird thing about how you add up numbers in general. Like I forget the last math I saw about it, but given the length of the wire, oh yeah, he was doing some aluminum magnet. Believe that shit. Seen a board stretcher and aluminum magnet, a real one that like you set a coil around it and it's inlaid with a thick beastie, which I would change. I would start to work in the geometry on that. You want to that copper inlay of the electromagnet steel that you did. Maybe that's a pipe dream, and you got to inlay it with copper, and that's how there's certain resonance on why that copper interlay being around an electromagnet creates that lens law effect in there that actually with a strong enough current might be able to at least attach to aluminum or copper as an index, because straight off the hop aluminum and copper, I bet you it's loosely or very weakly attracted to gold or something like that as far as what it does. Maybe useful, maybe not, who knows. But I want to talk about quarks in general on the mill floor. They're a weird thing. They're in this while I'm trying to do all that black and white. And so I might reference this same argument with a directional model, a ray, or a pawn that's moving in a specific direction, where quarks or anything I do, things like I'm loading the table after I've passed the learning curve. I've pushed through the Schwarzschild's radius. I maintained orbit, and I'm feeling pretty comfortable about it. I'm way what's up there on the charts, and you can tell that by the pawn that's on the table, right? And the charm for that is that there would be some other top level A inside of there against some idea that this kid came out with this very unique idea that's a charming aspect. It's definitely on one of the tops for what that spin does. When those individual components, or here's what I thought was up, it wasn't really certain and I wasn't sure about the ideas, but going to that there, I'm catching some charms to say overall, if I get those charms without any stranges or zeros, then that'll define what the top and bottom is for these two pieces over here, using those dings and bings and sounds that come into the frequency domain of what that does. The pion here is a green light and red light. Even though there's a red light, there's still a reason to speed. And if you looked at that math and you get down there to what's going to be how we have those little charts set up, there's combinations of those things. So what happens here is this quark arrow, and that's that Zeno's paradox in time. And it's specifically here because they're not really quarks, are they? They're directional models inside of that small little universe that I'm now microcosming from the bottom to say, well, positive aspects of now I understand those negative functions is a right-handed rule to the entirety of that entropy remaining on the high E I pi, right? Because then this whole function, red and anti-green, is a whole unit of a superposition. As long as I generally define it, let's say the periods and about computer engineering, you get there. But eventually, he'll get into why these have anti-quark or quark arrows. See, there's a set of these, I'd imagine, that have this principle without this, or that because to build that first, I have to build it in the form that there's a mu aspect to it, or a here an elect well here because right hand rule, but that is a mu electron, and specifically gravity is a negative here, like electricity. It wants to pull that draw, and on the top line create a push. So that's why when you have a negative 9 volts and you needed a key for an example, and you knew what you were doing the correct way, well, that pumps in the correct voltage, and that'll do its little de-flip-flop all the way through what it needs to do before that pushes one out through the pipes without it going through any of the other stuff that you don't want it to do. Now maybe you have shielding for that, and maybe you don't. Maybe that matters, and maybe that's why some of that other state would say that they're ordinary standards like this, or it's some combination of that event with some shielding or magnet, a ferrite, what is it, a ferrite magnet around that, some iron, just to help pull down some of the stuff going out in that input coming in that wire. Spicy through, yeah. Well, this keeps pushing out, and because of that geometry, you get these cool little charts like that, or they come in these time before they go beat the hell out of the serpent for using tools. You get these breakdowns of why they're in different states like that, and they're apparently giving the AI driver doing some pipe maze, right? You have this standard of what the idea is. That's my car. I've been watching it evolve, and in one set, I have 3 of the cars do what is it, 0.5 left, 0.5 right, and 0.1 right off of the initial one frame of instance, and it throws the whole thing off into a bunch of celled sets. But generally what you're thinking is, okay, instead of the fastest car or the slowest car, there's some period 0.5 in the middle where you got to start grabbing those middle ones, or at least marginally prepared minimum ones, right? Because then it'll give you the quarters that you need to throw that whole one, and say that's the field out there. That's what the race car would be missing if their pit crew was really that good into it. And I'm not saying they don't come in states like that, where the race car driver is amazing, or the pit crew driver is amazing, and depending on how you bifurcate that, oh boy, she got some charm. Woo.